This is 2.3, estimating derivatives. So it says estimate the derivative with a calculator. Okay, so remember, we're not doing any of this with a calculator. This is all going to be done on Desmos, which is so much easier than the calculator, because if we were using like a TI-84 or a TI Nspire, you would have to remember to click certain buttons in order to estimate this derivative. But for Desmos, all we have to do is type in the function and then f prime of that function, so the derivative of that function, and it will give us the value right off the bat. So for example, number 1 says f of x is equal to sine square root of x. So I'm going to do f of x equals, and then sine square root of x. Okay, that's my function. And then I'm going to do f prime of 2. There it is. And there is my answer. The only thing you have to be very cautious of is to make sure your Desmos is in radians. So off to the side where you see that little wrench, if you click on it and you scroll down, you see that mine was in radians right here. Okay, so the answer that I got for this is that f prime of 2 is equal to 0.0551. Okay, you would do the same thing for each of these. Okay, so I'm going to do one more, and then I'm just going to go back to the screen. So again, you're going to type in f of x, or what you could do is even just erase what you have up here, right? F of x is the natural log of 1 divided by 5 minus x. And then here it wants us to find f prime of 1.3, which I see here is 0.2702. So f prime of 1.3 is equal to 0.2702, or actually 0.3, because I want to round it properly, 0.3. Okay. So anytime it's asking you to estimate a derivative, or it wants you to get as an exact value as possible, you're just going to plug it into Desmos exactly like we did. The only thing, again, is to make sure it's in radians. Okay, if you leave it in degrees, you are going to get the wrong answer. Okay, so number 3 says write the equation of the line tangent to y is equal to the square root of x over x cubed plus 1 at x equals 1. Okay, well, in order to find this, we have to find first the point, then the slope. So remember that the point, in order to find this, we have x, so we know 1 is going to be x. Okay, but then we need to find y, and we would do that by plugging 1 into x. And you would just do that on Desmos, and you would find that you would get 0.707. And then our slope is just going to be y prime at 1. Okay, so you would plug in this, and then you would do, on Desmos, instead of y, I would just do f of x and then f prime of 1. And then when you do that, you get negative 0.1767. And then you would just plug it into your point slope formula. So y tangent minus 0.707 is equal to negative 0.176 x minus 1. And that would be your answer. Okay, estimating derivatives from tables. So it says the function must be differentiable to estimate a derivative. This just means that the graph is continuous and smooth. So the graph has to be continuous and smooth in order to estimate a derivative. So here we have a table, x representing hours and f of x representing miles. Okay, so it says using the table, estimate f prime of 3 and show the work that leads to your answer. Well, looking at this table, I don't see an x equals 3 on here, but I know it's going to be between 2 and 4. So I'm just going to be using the points surrounding to estimate that value. So I know that f prime of 3 is the same as saying f of 4 minus f of 2 over 4 minus 2. Well, f of 4 is 10 minus f of 2, which is 3 over 2. So this is 7 over 2. And then if I look back at the table, I'm able to get the units, right? So f of x is miles, x is hours, so this is miles per hour. Okay. So if I was to interpret this, I would say at time x is equal to 3 hours, the number of miles is increasing at a rate of 7 over 2 miles per hour. Okay, and we're going to do the same thing for the next one. So it says use the table and estimate W prime of 100. Notice X is seconds and W of X is gallons per second. Well, I don't see a 100, but I know 100 is between 80 and 120, so I'm going to be using these 2 points surrounding 100 to estimate. So I have W prime of 100 is equal to W of 120 minus W of 80 over 120 minus 80. I get 500 minus 700 over 40, which is negative 200 over 40, which is negative 5. And then looking at my units, notice it's gallons per second per second. So this is going to be gallons per second squared. And then my interpretation of this would be at time x is equal to 100 seconds, the number of gallons per second is decreasing because I have a negative rate of change at a rate of 5 gallons per second squared. Okay, notice that since I mentioned decreasing, I did not have to put at a rate of negative 5. Okay, it is counterintuitive to write both. So just write decreasing and then write your number.